You've definitely seen them. You've probably even flipped one back on yourself. But have you ever stopped to think about what that little switch in the electrical box is really doing? Well, today we're going to dive deep into the humble yet absolutely vital circuit breaker, the silent guardian of our entire electrical world.
We have all been there, right? You're going about your day, maybe you plug in one too many things, and poof, the lights go out. So you head off to the basement or some closet to flip a switch. But what just happened in that split second? What was it that just saved your home from a potential disaster?
At its heart, it's pretty simple. A circuit breaker is just an automatic safety switch. Its one and only job is to constantly watch the flow of electricity. And the second it senses a dangerous surge, whether that's from an overload or a short circuit, it slams on the brakes and cuts the power. It is the absolute first line of defense for everything from your phone to your family.
Okay, so to really get a grip on these things, let's start where it's most familiar. Our own homes. We're going to begin with the tiny guardians inside our walls, the ones protecting our families and all our gadgets day in and day out.
What's so cool is that your breaker box isn't just one type of switch. It's like a whole team of specialists. You've got your basic breaker that stops overloads, for when you run the microwave and the toaster at the same time. But then you have others that are even smarter. Some are literal lifesavers, detecting tiny electrical leaks to prevent a nasty shock. And some can even hear the dangerous crackle of sparks inside your walls that could lead to a fire. It's amazing stuff.
All right, let's zoom out a bit. We're moving from our homes to the places that power our economy. Factories, data centers, huge office buildings. And let me tell you, the electrical demands here are on a whole other level. And so are the circuit breakers.
And wow, this really puts that jump in scale into perspective, doesn't it? On the left, that's the little guy from your house. On the right, that's its industrial big brother, the Molded Case Circuit Breaker, or MCCB. It does the same basic job, but it's built like a tank to handle the massive currents needed for heavy machinery and entire buildings.
So how much more current are we actually talking about here? Well, that breaker in your home might trip at, say, 15 or 20 amps. An industrial MCCB, it can be rated for 1,600 amps, or sometimes even more. That is a mind-boggling difference in power.
And if you go into the biggest industrial plants, you'll find the top dog, the air circuit breaker. Just think of this one as the main gatekeeper, the head of security for an entire factory's electrical system. It's the ultimate line of defense against a catastrophic failure.
Okay, time for our final biggest zoom out. We're going to the largest scale imaginable, the high-voltage grid that connects power plants to all of our communities. Protecting this massive system, well, that's a whole different ballgame. It requires some seriously incredible engineering.
See, the big challenge at this scale is stopping an insane amount of power. At these high voltages, electricity doesn't just stop. It can literally jump through the air, creating a dangerous arc, almost like a miniature bolt of lightning. So to stop it, these huge breakers use some wild technology. Some create a perfect vacuum, others use powerful blasts of compressed air, and some even use special insulating gases just to safely snuff out that arc and shut down the power.
So, who are the masterminds building these critical pieces of our global infrastructure? It's actually a small club of highly specialized worldwide engineering giants. These are the companies that design and build the very devices that keep our power grid safe and stable.
But think about it. How can we be 100% sure that a device designed to prevent a disaster will actually work when it matters most? Well, the answer is testing. And I mean rigorous, relentless, hardcore testing. It's how we build trust in these critical guardians.
It really boils down to two key stages. First, there's the factory acceptance test, or FAT. This happens in a controlled lab before the breaker ever ships, just to iron out any and all kinks early on. Then, after it's installed on location, there's the site acceptance test, or SAT. This one makes sure it's ready for prime time in the real world, connected to the actual system it's going to protect.
And when I say testing is thorough, I mean they check everything. Technicians go over it with a fine-tooth comb. They test electrical resistance down to the tiniest fraction, and they measure its reaction speed in thousandths of a second. Every single safety feature is pushed to its limit to guarantee it will perform flawlessly when called upon.
So we know what they are, we know how they work, and we know they're tested like crazy. But just how widespread are these silent protectors? Turns out they're working all around us, all the time.
They're right there at the very source, protecting the massive generators and transformers inside our power plants.
They stand guard all across our national power grid, isolating problems in a split second to prevent huge blackouts.
They're absolutely essential for our green energy future, too, safeguarding sprawling solar farms and massive wind turbines.
And they literally keep us moving, protecting the complex electrical networks that power our modern train systems. You know, when you really step back and take it all in, the picture becomes crystal clear. From that tiny little switch in your wall, all the way to those colossal breakers that manage the national grid, they truly are the invisible and absolutely essential guardians of our modern world.
So I'll leave you with this one final thought. The next time your lights flicker for just a second and then pop right back on, don't get annoyed. Instead, just take a second and maybe even smile. Because now you'll know that somewhere out there, a silent guardian just did his job perfectly and you probably never even noticed.